Hello students, welcome all. In the last session we have discussed what is rate of change and what is monotonicity and what is maxima and minima. We have been seeing maxima and minima in the past session and we have discussed what is the definition of maxima or minima of function. For a function at a point that will be denoted as local maxima or minima or local extremum, and what is a function value, maximum value and minimum value in the entire domain, that is global maximum and global minimum. We have seen the definition as well as the test for finding if the function attains a maximum or minimum value, that is given by first derivative test and second derivative test. We have also seen what is nth derivative test. In this session we will see few problems by solving using second derivative test to find the maxima or minima of different functions, and then again we will solve few word problems. We will start with this problem. Find the global minimum value at the point of global minimum of some function in real numbers. So domain is real number and this is a polynomial function. To be exact, it is a quadratic function. And we already know the graph of quadratic function. So the quadratic function will be concave upward when x square coefficient is positive. So this function don't have a maximum value because at minus infinity and infinity, that is the extreme ends of domain, this function value will tend to infinity. We already know that. So this function only has a minimum value and we need to find the minimum value of this function. We will start by first one is take the function f of x. How to find minimum and maximum value for a function? At minimum or maximum value, derivative, first derivative should be 0. So we can write f dash of x. What is f dash of x? Differentiate this function, we will have 8x minus 4. So f dash of x is 8x minus 4. Next, what we need to do, students? Equate f dash of x equal to 0. So f dash of x equal to 0 means we will get 8x minus 4 equal to 0, which means what is the value of x? 4 by 8, that is 1 by 2. So x value comes out to be 1 by 2. Okay, now what we need to do? Check the double derivative at the critical point. Always remember, when we are finding maxima or minima, to check exactly at which value the function will attain maxima or minimum value, by using double derivative test, first we will write the double derivative, that is f double dash of x. What is f double dash? We have to differentiate f dash again, that will be 8. Next, what we need to do? At f double dash at the critical point, that will be f double dash at 1 by 2. Again this value is 8. Now we have to check at the critical point if the function attains positive or negative value. So 8 is a positive number greater than 0. What is the condition by using second derivative test? If f double dash is greater than 0, then this point will correspond to minimum value, which means x equal to 1 by 2 is a point of minima. Is a point of minima. Is a point of minimum. Okay, now what is the minimum value? If we have to find the point of minima, that is x equal to 1 by 2. If we have to find the minimum value, that will be f of 1 by 2. Always remember, when we are finding f of 1 by 2 minimum value, remember to substitute this value in the given question, given function. And another common mistake students will commit is, when we are finding double derivative, don't think if this value is greater than 0 or less than 0 by just taking any example. Don't consider an interval for this double derivative. Always check, first equate critical point, find the critical point by substituting f dash equal to 0 and find the x value. Only at those points check the double derivative value. So in this point, x equal to 1 by 2, if it is greater than 0, that is a point of minima. If it is less than 0, then it will be a point of maxima. So f of 1 by 2 value is, substitute 1 by 2, 4 into 1 by 2 square, that will be 1 by 4, minus 4 into 1 by 2, minus 4 into 1 by 2 plus 11 plus 11. So what is the value? 4 by 4 is 1 minus 4 by 2 is 2 plus 11. What is the value, students? 1 minus 2 is minus 1 plus 11, 10. So minimum value is 10, global minimum value will be 10 and maximum value does not exist for this function. Always remember, when we have to find local minima or local maxima, then it will be interior points. So we just need to proceed with this step. But when we have to find global maximum or global minimum, we also have to check the extreme points. But for this question, as it is defined in all real numbers, at minus infinity and infinity, that will be the end points for this. So at those points, this function will tend to infinity. Why is that? Because when we substitute, suppose infinity in the place of x, then infinity square will be always greater than infinity. That means we can't change that here. Okay, so when we have to find global maxima or minima, we also have to check, other than the critical point, we have to check at the end points of the interval. So at the end points, this value infinity square, that will be a bigger number than infinity. So what we understand from this term will always tend to infinity. Similarly, for minus infinity, its square will be infinity. So this term will always tend to infinity, which is undefined. That means when the function goes to undefined numbers, we don't have a maxima or minima number. So this value is actually undefined, but minimum value exists for this question. So only this question, even though it is given as I'm not using this pen.
Use sir for black. Sir, use this for color change. Dark color. Wait. From where you are using pen?
This
here.
PPT or your
PPT pen.
Okay, PPT pen. Use board pen.
board
Okay.
can use this one, sir. This
Then
one.
each time I have to click delete and
It's
you
okay.
know. Okay.
But use darker colors, not green.
Okay, I'll use white color.
Black.
Black won't be visible here. I will use white color.
This is blue screen, na black it is visible.
Okay.
On that computer scene, on that scene there, on that screen see. That
Okay.
is not visible. But if you are using white na, so thick the pen.
Okay, sir.
Okay. पेन की जो थिकनेस है वो इंक्रीज कर दो.
I think.
जैसे कि अभी इतनी है, इसको या तो इतनी कर दो या इतनी कर दो.
Okay.
See.
Okay. This color is good now, white. Okay. So this is how we should solve this question. So what is the minimum value? That is 10. Okay. Now we will see the solution. So x comes out to be 1 by 2, x is equal to 1 by 2, and at x equal to 1 by 2, what is f double dash? F double dash value is 8, we have already seen that, which is greater than 0, that means 1 by 2 is a point of minimum. So what is f of 1 by 2? That is the minimum value, so that comes out to be 1 minus 2 plus 11, that is 10. So global minimum value is 10. Next question, find the points of local minimum and local maximum of the function f of x equal to sin x, sin 2x. This is a trigonometric function and x belongs to 0 to 2 pi. Okay, now we will solve this question. First step is differentiate this. F dash of x will be equal to, what is the differentiation of sin 2x, students? Differentiation of sin 2x is, sin differentiation is cos, so cos 2x multiplied by 2 cos 2x. Next, what we need to do? Equate f dash of x equal to 0. F dash of x equal to 0, which means we will get cos 2x will be equal to 0. Cos 2x equal to 0. And when will the cos become 0? At odd multiples of pi by 2, 90 degree, 270 degree and so on. So that means this 2x will correspond to odd multiples of pi by 2. So 2x will be pi by 2, 3 pi by 2, 5 pi by 2 and so on. Now what is given in the question? X belongs to 0 to 2 pi. That means x belongs to 0 to 2 pi. That is given. It is in closed interval. That means we have to include the boundary values. That means what is the range of 2x? That will belong to 0 to 4 pi. 0 to 4 pi. Which means x belongs to 0 to 2 pi. 2x belongs to 0 to 4 pi. Which means we have to find this value of 2x up to 4 pi. Then what value we need to include? Pi by 2. It belongs to this interval. 3 pi by 2, that is 3 by 2 is 1.5. 5 by 2 is 2.5, which is less than 4. 7 pi by 2, which is 3.5, again less than 4. 9 pi by 2, which will be 4.5, that is greater than 4 pi. So we need to find up to this 7 pi by 2. How many values are there, students? 4 values, which means x will be equal to, just divide by 2, then we will get pi by 4, again 3 pi by 4, 3 pi by 4, again 5 pi by 4, 5 pi by 4, again 7 pi by 4, 7 pi by 4. Now we have got 4 values for x. Next, what we need to do? Substitute at those points what will be f double dash. So first we need to find f double dash of x. F double dash of x, that will be equal to, what is f dash? 2 cos 2x. Differentiate this. So we will get 2 into 2 will be 4. Cos differentiation is minus of sine. So minus 4 sine 2x. This is f double dash. Now what we need to do? Equate at f double dash of critical point. So f double dash of pi by 4 is, what is the value? When you substitute pi by 4 in place of x, 2x will be pi by 2. So sin pi by 2 is 1. That means this will be minus 4 sin pi by 2, which is nothing but minus 4. And what is minus 4? This number is actually less than 0. So f double dash at pi by 4 is less than 0. Which means what is the value of x at pi by 4? This function attains maximum value. So f equal to, not f, sorry. X equal to pi by 4 is actually a point of, maximum. Clear, students? Now what we need to do? We already seen x equal to pi by 4 is a point of maximum. Then we need to check what is f of pi by 4. That will be the maximum value. So maximum value is given by f of pi by 4. That will be equal to, what is f of pi by 4? In place of this function we have to substitute. That will be sine of 2 times pi by 4, that is pi by 2. What is sine pi by 2? 1. Similarly, we have to solve for other cases. Now what will be f double dash of? Next value is 3 pi by 4. 3 pi by 4. That is equal to, what is f double dash? This function minus 4 sine 3 pi by 2. 3 pi by 2. 2x is 3 pi by 2. And what is sine 3 pi by 2? Sine 270 is minus 1.
Use pen from tip side.
Okay.
It is hurting the screen. That's why.
Okay. So minus 4 sine 3 pi by 2, that is equal to, this is sine 3 pi by 2 is sine 270 is minus 1. So this value is 4. Clear now students? And what is f double dash at 3 pi by 4? This is greater than 0. That means when f double dash is greater than 0, then x equal to 3 pi by 4 is a point of minimum. Is a point of minimum. Okay. Now what is the minimum value? Minimum value is given by f of 3 pi by 4. 3 pi by 4. Minimum value is f of 3 pi by 4. That is equal to, what is f of 3 pi by 4? Sine 3 pi by 2. Sine of 3 pi by 2. That is equal to minus 1. So minus 1 is the answer. For minimum value is minus 1. And it attains the value of x, that is 3 pi by 4. Similarly, we have to solve for the other two cases. I think procedure is clear now. We will see with the solution. Other two steps will be similar. So again we have to check for 5 pi by 4, f double dash at 5 pi by 4 and f double dash at 7 pi by 4, and see if it is positive, then that is a point of minima. If it is negative, that is a point of maxima. And for maximum or minimum value, substitute those values in f of x. Procedure is same. Okay. Now we will see the solution. F of x is sin 2x, f dash is 2 cos 2x, f double dash is minus 4 sin 2x, f dash equal to 0 means cos 2x is 0, which means 2x is odd multiple of pi by 2. So x value will be divided by 2, pi by 4, 3 pi by 4, 5 pi by 4 and 7 pi by 4. That means when x is equal to pi by 4, what is the value of f double dash? That is minus 4, that is less than 0. Similarly, maximum value will be x equal to pi by 4. So substitute f of pi by 4 is the maximum value, that is 1. Similarly, at x equal to 3 pi by 4, f double dash becomes greater than 0. So this point is actually a point of minimum. When f double dash is greater than 0, x is a point of minimum. And minimum value is f of that point, that is 3 pi by 4. So what is the answer? Minimum value is minus 1. Again at x equal to 5 pi by 4, f double dash is minus 4 sine 5 pi by 2, which is less than 0. So this is a maximum point and value is f of 5 pi by 4. That is sine 5 pi by 2, which is 1. Similarly, we will find at x equal to 7 pi by 4, f double dash becomes greater than 0. That means it is a point of minimum. And minimum value is f of 7 pi by 4. That is sine 7 pi by 2, which is minus 1. So these are the maximum and minimum values. Now we will discuss some problems related to word problems, word statements. And this is a very important topic, students. Questions based on case studies can be asked from this, as well as some questions for mains can be asked from this, and also it is useful for question can be asked based on 1 mark or 2 mark questions from this topic. Sometimes even 3 more questions can be asked from this topic. So this is a very important topic, word problems. For solving these problems, there are certain steps which we need to follow in general. Questions will be descriptive and we need to break it into different parts. I will explain how to do this. First, what we need to see is, question is find two positive numbers. Here we have two variables, two numbers. We don't know the numbers. So first step is to assume two numbers. Let's assume this numbers as let's take these two positive numbers as x and y. Let's take these two positive numbers as x and y. Okay, what is given? Sum is 15. Sum is 15. This is the condition that is given, which means sum is 15 means sum of these two numbers x plus y is equal to 15 and sum of their squares is minimum. What is the sum of squares of numbers? X square plus y square. This value is minimum. We don't know this value of this, so we will take this is a function in terms of x and y. So f of x comma y is equal to x square plus y square, and the given condition is x plus y equal to 15. For solving such questions, the first step is to see the question and see how many variables are there. Then what we need to do? Take this part, given condition, and write in mathematical term. That is, sum of two numbers is 15 means x plus y is equal to 15. Then what is given? Sum of their squares is minimum. That means we have to minimize the sum of squares of two numbers. So we already learned in maxima or minima, for maximum or minimum, first derivative should be equal to 0 for continuous and differentiable functions. So what we need to do is take the function which needs to be maximized or minimized. In this question, we need to minimize sum of squares of two numbers. So take that function that is taken as f and find the first derivative and equate it to 0 for maximum or minimum. That means first what we need to do is we are differentiating. That means we already learned how to differentiate in a single variable. So we need to convert these two variables into a single variable first. And how to do that? By using the given condition, given relation, that is x plus y equal to 15. So what we need to do is x plus y equal to 15 means we can write y in terms of x. That will be y is equal to 15 minus x. Now we will substitute this value here. So we will get f of x will be equal to x square plus y is 15 minus x. So this will be 15 minus x whole square. Now this is a minus b whole square expansion. That will be a square plus b square minus 2ab. So here we will get x square term, and we already have a x square term. That will be 2 times x square minus 2ab, that will be minus 30x plus a square, that is plus 225. This is f of x. Next what we need to do? First derivative is 0 for maximum or minimum. So f dash of x equal to 0 for maximum or minimum. And what is f dash of x? Implies we will get f dash is 4x minus 30 minus 30. This should be 0 for maximum or minimum. So which means x is equal to 30 by 4. And what is 30 by 4? 15 by 2. Next what we need to do? Find f double dash of x. F double dash of x. F double dash of x is equal to, what is double dash? Differentiate this again, that will be 4. F double dash is equal to 4, which means at the critical point f double dash at 15 by 2 is also 4. This number is greater than 0. When f double dash at the critical point is greater than 0, that means x attains minimum value at that point. A common confusion that is coming is when we are finding f double dash equal to 4, that means it does not mean the entire function is minimum. Why is that? What does this f double dash second derivative signify? This means rate of change of slope. That means how the curvature of the curve changes. That is denoted by x f double dash. So how the curvature of the curve changes. So here curvature does not change, and if double dash is positive means the curve is concave upward. So that means this point will be a point of minimum. Concave upward curve, for concave upward we will have a minima value. So this curve is always positive means minimum value, not at all the points. So that's why we are checking at the critical point what is the curvature of this curve. So that means we will have 15 by 2, x equal to 15 by 2 is a point of minimum. Is a point of minimum. Now what we need to see? Sum of their squares is minimum. Sum of their squares is minimum when x is equal to 15 by 2. What we need to find? Find two positive numbers. That is, we have to find x and y. Okay, we already got x value. What is the value of y then? Y will be equal to 15 minus x. That will be 15 minus x is 15 by 2. That is again 15 by 2. 15 by 2. So x equal to 15 by 2 and y is equal to 15 by 2. This is the solution for this. Now we will see the solution. X and y are the two required positive numbers. Let's assume that two positive numbers. See the condition, sum is 15. So that means x plus y is 15 and sum of their squares is minimum. Sum of their squares is x square plus y square. Write in single variable and then differentiate, equate it to 0. We will get x value. X value comes out to be 15 by 2. Now f double dash at this point will be greater than 0. So that means it is a point of minimum. And sum of squares is minimum at x equal to 15 by 2. So at when x is equal to 15 by 2, what is the value of y? Y is again 15 by 2. So numbers are 15 by 2 and 15 by 2. Suppose find the minimum value of sum of squares. If question is framed like that, then we need to find x square plus y square. That is 15 by 2 square plus 15 by 2 square. Depending on what is asked in the question, we have to solve. Same question can be asked in that way also. Next question, it is again a similar question. Here what is given? Find two positive numbers x and y. They have given the numbers x and y such that x plus y equal to 60. Okay, they have given the condition also. And xy cube is maximum. Okay, x plus y is 60 and xy cube is maximum. Now how to solve this? Here we have f of x comma y is, we have to maximize xy cube. So solution will be f of x comma y should be taken as xy cube. Then what we need to do? Use the condition, convert it to single variable. Now if we write x in terms of y or y in terms of x, both are okay. But in this question we already have y cube. That means it will be easier to solve when we convert x in terms of y for this question. So what is x in terms of y? From this relation we get x is equal to 60 minus y. So we can write x is equal to 60 minus y into y cube. That is nothing but 60 y cube minus of y power 4. Okay, 60 y cube minus y power 4. Now what is, this is nothing but f of y. Okay, now what is f dash? For maximum or minimum, f dash should be 0, which means f dash of y is 60 into 3, 180 y square minus 4 y cube, 180 y square minus 4 y cube. This is equal to 0. Now what is common? 4 y square is common, which means 4 times y square into remaining we have what is 4 into 45 is 180, so we will get 45 minus y equal to 0. Now what is the value of y from this? Which means y is equal to 0 or y is equal to 45. Now obviously when we observe from this, y cannot be 0. Why is that? We have two positive numbers. 0 is a positive number or not? No. That means it does not satisfy the condition. Also, we have to find the maximum value. When y is equal to 0, this product is actually 0. If we have any positive number, that will be greater than that. Therefore, 0 is not possible. Only 45 need to be selected. Okay. Now what is f of 45? Okay, we already, only we have to find two numbers now. So we have to find x and y. That means we already know y value. What is x? X will be equal to, y is equal to 45, which means x will be equal to 60 minus 45. 60 minus 45, that is equal to 15. Now to check if this is a minimum value or not, what is a condition we apply normally? Find f double dash. We will see the condition also. Check is f double dash of, we are differentiating with respect to y. Function is in terms of y. So again, this is the function. What is f double dash of y? 360y minus 12y square. 360y minus 12y square. And we have to check if this value is negative or not. If it is a negative number, then this product is maximum. So f double dash, obviously at 0 it will be 0. That means when f double dash is 0, it is neither maximum nor minimum. And f double dash at 45 will be, just substitute the value. 360 into 45, 360 into 45 minus 12 into 45 square. Minus 12 into 45 square. Now what is the value of this? 45 is common. We can take 45 outside. Remaining 360 minus of 12 into 45. Okay, 10 into 45 is already 450. That means this number is a negative number. So product will also be negative. We don't need to calculate. F double dash is less than 0. Which means this is a maximum point. So x equal to 15 and y equal to 45 is our required answer for x and y. So the two positive numbers will be, we will take x plus y is 60, means x equal to 60 minus y. For the same question, we can also replace y in terms of x and again solve. F dash of x equal to 0 and use the same procedure. But for that, we need to simplify first f of x because it will be a cubic equation. F dash equal to 0 means we will get 4y square into 45 minus y, that is equal to 0. So y is equal to 0 or 45. Now what is f double dash? F double dash will be negative number, that means it is a point of maximum. So what is the value? Y is equal to 45, then x will be equal to 15. So the required numbers are 15 and 45. Next question. Find the maximum area of rectangle that can be formed with fixed perimeter. Okay. Find the maximum area of rectangle with fixed perimeter. Let's take length as x and width as y. What is the perimeter? 2x plus 2y. 2x plus 2y. This is equal to 20. 2x plus 2y equal to 20. Which means x plus y is equal to 10. X plus y equal to 10. Next, what we need to do, students? This is a given condition. So we have used the condition, established mathematical relation. Next, we have to see which is to be maximized or minimized. Find the maximum area of rectangle. So what is the area? Equal to xy. Area of rectangle is x into y, length into breadth. Now we have to replace in single variable. That means f of x equal to, what is y? 10 minus x. So we will write x into 10 minus x. X into 10 minus x. Okay, this is nothing but 10 into x minus of x square. Now we will do 10x minus x square will be f of x. So f dash of x will be 10 minus 2x. Now f dash of x equal to 0 means, f dash of x equal to 0 means we will get x is equal to 5. 10 minus 2x equal to 0. 2x equal to 10 means x is equal to 5. This means x is equal to 5. Okay, x equal to 5. Next, what we need to do? This is the critical point. So f double dash will be, f double dash of x is, differentiate f dash of x, that will be minus 2. Which means f double dash of 5 will be again minus 2, that is less than 0. Which means x equal to 5 is a point of maximum. X equal to 5 is the point of maximum. This is the point of maximum. What we need to do? Find the maximum area. So what is the maximum area, students? Maximum area is given by f of x, that is f of x value is 5. This is the maximum area. Now what is f of 5? F of 5 is 10 into 5 minus 5 square. 10 into 5 is 50 minus 5 square is 25. That is equal to 25 square units. That is it. Easy questions. Now we will see the solution. Here let x and y be the length and width of rectangle. Then we will get 2x plus 2y is 20. So x plus y is 10, or y is equal to 10 minus x. Area is x into y. So we will get x into 10 minus x, that is 10x minus x square. And f dash of x will be 10 minus 2x. Equate f dash of x equal to 0 for maximum or minimum. So that means x is equal to 5. Next, what we need to do? Find f double dash to check if that is a point of maxima or minima. This is a negative number, so that means x equal to 5 is the maximum point. And what is the maximum area? That is again substituting f of x. That is equal to f of 5. So that is 10 into 5 minus 5 square, which is 25 square units. Next question. A wire of length L is cut into two parts which are bent respectively in the form of square and circle. Okay. We have a wire of length L. This is cut into two parts which are bent in the form of a square and a circle. We are making a square and a circular portion with this. Then what is given? We have read up to this. Next is, what are the lengths of pieces of wire so that the sum of areas is least. So we have to find the length of pieces of these shapes, square and circle. That means we have to find the perimeter of square and perimeter of circle. that will be total length L. So what is the actual condition? We are splitting this wire of length L into two segments. So what is the, let's take this as x, side of square is x. That means perimeter of square will be 4x, and let's take the radius of circle is r. Then what is the perimeter of circle? Perimeter is nothing but circumference, that is 2 pi r. So 4x plus 2 pi r, that is equal to total length of the wire segment, that is L. This is the given condition. This is the given condition. Okay, here L is actually constant because we have a fixed length of wire and we can change the x as well as r variables. We can split the wire in different parts so that the perimeter of square as well as perimeter of circle can vary. That means L is fixed. So this is a constant number, say 10 or 15, think of it like that. This is not a variable actually. And x and r are variables. Now this is the given condition. Next, what is asked? What are the lengths of pieces so that the sum of areas is least? So we have to find the area of square as well as circle and add that sum should be least number. So that means area is given by, this is a function of x and r. X and r are two variables here. That is equal to, what is the area function? Area of square is x square. Area of square is x square plus area of circle is pi r square. Next, what we need to do, students? We have to convert in single variable. How to do that? We can find x with related to this. So from this relation we get x is equal to L minus 2 pi r divided by 4. L minus 2 pi r divided by 4. Now we will substitute the value here. That means L minus 2 pi r whole square, divided by 16, that is x square, plus pi r square. Now we have write this in terms of single variable, that is r. Next, what we need to do? F dash of r is equal to 0. That is given by, differentiate this, 2 times of L minus 2 pi r, divided by 16 into, we have to differentiate L minus 2 pi r, that will be minus 2 pi, into minus 2 pi plus 2 pi r equal to 0. F dash equal to 0. Here what is common? 2 pi is non-zero number, so we can cancel out this, which means we will get, here this will be cancelled, so we will get 8. That means r is equal to L minus 2 pi r divided by 8. So 8r will be equal to L minus 2 pi r. Clear now, students? R is equal to, take this term, first term to the right hand side, then this minus will become plus. We will have L minus 2 pi r divided by 8, cross multiply 8. Then 8r is equal to this value, which means we will get 8 plus 2 pi into r, 8 plus 2 pi into r, 8 plus 2 pi into r equal to L. R is equal to L by 8 plus 2 pi. Next, what we need to do? Find 2 pi r, because that is the length of circle. 2 pi r will be equal to 2 pi L into divided by 8 plus 2 pi. 2 is common in the denominator, so we can cancel out. This will be pi L divided by 4 plus pi. Now r, 2 pi r is pi L by 4 plus pi. This is the circumference of circle. Now we have to find double dash, double derivative, and again check if it is negative or positive. So this value will be maximum or minimum. Right now I am not doing this second derivative. We will see that with the solution. Now R value 2 pi r circular region is pi L by 4 plus pi. Next what we need to do? Find the value of L. Sorry, yeah, it is X. So what is X? X is equal to L minus 2 pi r, L minus 2 pi r divided by 4, L minus 2 pi r, pi L by 4 plus pi divided by 4. So we can take 4 to the other side, and 4x is nothing but perimeter of square region. So what is the perimeter of square? That is given by cross multiply 4L plus pi L minus pi L divided by 4 plus pi, and that equals to plus pi L minus pi L will get cancelled, remaining 4L divided by 4 plus pi. So the required answer is, the required area of circle is, perimeter of circle, length of wire that forms the circular region is pi L by 4 plus pi, and for square it is 4L by 4 plus pi. And we have to check if this value actually gets a minimum value or not at these points of X and R. Now how to do that? Find the double derivative f double dash of R and substitute the values of this f double dash of R and substitute the value L by 8 plus 2 pi in that. Check if it is negative or positive number. That is the procedure. Now we will see the solution. So wire of length L, that is split into two parts. Let the parts be X and L minus X. That means this X is the total perimeter, and that is given by, if the side is Y, X will be 4Y, and R is the circumference. That means we will have 2 pi r, that is L minus X, remaining portion of the segment, lower segment. So instead of taking two variables X and Y, we can also directly write X is the side, means 4X is the perimeter. Similarly, we can find circumference. So sum of areas should be minimum. Sum of areas is given by y square plus pi r square. And convert it into single variable and find f dash. F dash equal to 0 means we will get X value, that is 4L by pi plus 4. What is X? That is the perimeter of square. And again f double dash of X is greater than 0 means this value is minimum, and sum of areas is minimum means find the value of length of square as well as circular region. So that comes out to be 4L by pi plus 4 and pi L by pi plus 4. So the length of pieces are 4L by pi plus 4 and pi L by pi plus 4. Y 4x. Because in the question we have to find the perimeter that gives the minimum area. What is the perimeter of square region? If side is X, 4X is the perimeter. We already know how to find perimeter. Perimeter is what? Add all the sides. That will be the total wire segment that forms the square region. So that will be 4x. That is why we take 4x. Clear now? Why we have 4x? 4x is because we take the square segment that is use the wire for forming the square region. So that will be 4x. In this question we have X is the total perimeter and Y is the side. So 4Y will be equal to X. That is what is given in this solution. We can directly take X is the side means 4X is the perimeter. Clear now? So the perimeter of side as well as, perimeter of square as well as circular region is what we need to find. That is X and L minus X. So perimeter of square region is 4L by pi plus 4 and circular region is pi L by pi plus 4. Next question. From a rectangular sheet of dimensions 30 by 80 centimeter, 4 equal squares of side x centimeter are removed at the corners. Okay, now what is given? From a rectangular sheet of side 80 by 30, of side 80 by 30, we are removing 4 regions. We are removing 4 regions. Okay, this part is cut. This part is cut. And what is the length? This is x. This is again x. X. Okay. We are cutting these portions at the corners. These are removed at the corners. And the sides then turned up so as to form a open rectangular box. Okay. Remaining side is turned up. Now let's connect this. Now what we are doing, after cutting this portion, we still have this portion left. We have this portion left and we are turning this, folding this up so that this forms a open rectangular box. Why is it an open rectangular box? Because top portion is not closed. When we are folding this after cutting, removing this corner portion, while turning up, it will form a rectangular region. So that is why it is an open rectangular box. Then what is us? Find the value of x. We have to find the value of x so that the volume of box is greatest. Volume of box is greatest. Okay. When will we have volume is greatest? Volume of box formula is given by, what is the volume of rectangular box, open rectangular box? This is in the form of cuboid, that is L into B into H. That means we have to find the base area. We have to find the area of this portion. And this area multiplied by height, that will give the volume. So what is the value of this area? This is given by, this length is actually 80 total length minus of, we have to subtract this x and x. So this will be 80 minus 2x. 80 minus 2x. And what about this region? Again we will only have this portion. So that will be 30 minus 2x into 30 minus 2x into, what is the height? Height will be x. Height is x. Now what is the volume of this? 80 into 30. 8 3s are 24. 2400. 30 into minus 2, minus 60. Minus 2 into 80, minus 160. So minus 60 minus 160 is minus 220x. Then minus 2x into minus 2x, that is plus 4x square into x. That is equal to 2400x minus 220 . What we need to do? Volume is greatest. That means V dash equal to 0 for maximum or minimum. V dash is equal to 0. That means V dash is equal to, differentiate this, we will get 2400 minus of 220 into 2, that is 440 x. 4 into 3 is 12 plus 12x square. Now this value should be equal to 0. For maximum, this value V dash is equal to 0. So what is this? 4 is common. We can divide this value by 4, which means we will get 600 minus 110x plus 3x square equal to 0. Now factorize this. What are the factors? 3x square minus 110x plus 600. So product of two numbers should be 1800. Sum of numbers should be minus 110. What are the numbers? Product is 1800 and sum is minus 110. 90 into 20, 1800, 90 plus 20, 110. So we can split this as, I will write x square term first, minus 90x minus 20x, that is minus 110x plus 600 equal to 0. Now what are the factors? Here we will get 3x is common from the first two terms. So 3x into remaining will be x minus 30 minus of 20 is common, 20 into x minus 30 equal to 0, which means x minus 30 into 3x minus 20 equal to 0. Okay, that means x is equal to 30 or 20 by 3. Now when x is equal to 30, what does that mean? X is 30 means we are removing the entire region. That means we cannot form a rectangular box. That is not possible. That means x equal to 30 should be rejected. X equal to 20 by 3 is the answer. What we need to find? Value of x. Find the value of x. So x will be 20 by 3. Clear now students? This is how we should solve these types of questions. And for checking if this value is actually maximum or minimum, use second derivative test. Again find v double dash, that will be 6x minus 110. I will do it here. V double dash is equal to 6x minus 110, and at 20 by 3 what is the value? At 20 by 3, v double dash at 20 by 3 equal to 6 times of 20 by 3 minus 110. This is actually 40 minus 110, that will be a negative number. As v double dash is negative, this is a maximum, point of maximum. So it is correct, we have to find volume is greatest, that means we have to maximize the volume. So x equal to 20 by 3 is our required answer. Again, take the rectangular box. Total length is 80. In that we are subtracting 2x. From this side we are subtracting 2x from 30. So volume of box is given by 80 minus 2x into 30 minus 2x into x. So that is this function. And find f dash of x. That is this. F dash equal to 0 means find the value of x. So we get x equal to 20 by 3 and 30. X equal to 30 is not possible. So we get x equal to 20 by 3. And f double dash at 20 by 3 is negative number. So that means we get a point of maximum. If we have to find the maximum value of the rectangular box, maximum volume of rectangular box, then after that we have to find f of 20 by 3. That is it. Next question. Show that the curved surface area of a cylinder, curved surface of a cylinder inscribed in a sphere, curved surface of a cylinder inscribed in a sphere. For solving such questions, geometrical problems, first step is to draw the diagram. Okay, what is the diagram? Curved surface area of a cylinder inscribed in a sphere. So first sphere is there, and inside it we have a cylinder. Okay, there is a sphere, inside it there is a cylinder. Let this be axis. Okay, next what is given? Sphere of radius r. So sphere has radius r. Let this be radius r. Okay, so let the height and radius of cylinder be, okay, this is small x, small r. this is small r. Okay, now this is, let this be capital R, and the total height is capital H. That means by symmetry we can say this height is h by 2, capital H by 2, and this portion is r. By Pythagoras theorem we can write small r square is equal to capital R square plus h by 2 whole square, that will be h square by 4. This is the first step. Is it clear, students? By looking at the diagram, we have to construct the condition from this. In this question, condition is not given. So first we have to find the condition. How do we find the condition? We have a sphere and a cylinder and we have radius of sphere is small r, and let's assume radius of cylinder is capital R and height is capital H. By symmetry we can say this height will be capital H by 2, and from here this will be hypotenuse. So this is a hypotenuse, that is small r, and capital R is the radius of cylinder, and capital H by 2 will be the remaining portion that forms the right angle triangle. So that means r square is equal to capital R square plus h square by 4. This is our relation. Next, what we need to see, curved surface area of a cylinder is maximum. So this value is maximum. What is curved surface area? Curved surface area of cylinder is given by this circumference multiplied by height, that will be the curved surface area. So what is the circumference of this cylinder? The circle region, base region, that will be 2 pi into capital R, 2 pi into capital R into height. Height will be h. So this is our required function. Here this function is in terms of R and h. Okay, next what we need to do? Then the height of cylinder is root 2r. So we have to find h. We have to write this curved surface area in terms of h. Then we can find h dash, f dash at h equal to 0. Why is that? Because height is equal to root 2r. That is what we need to prove. So we have to write in terms of h. What is r in terms of h? R square is equal to small r square minus h square by 4, which means small r will be equal to square root of, take LCM, we will get 4r square minus h square divided by 2. Take the square root after that. So this is our capital R. Now substitute this value here. So we will get f will be equal to f of function is in terms of h, that is equal to 2 pi r will be square root of 4r square minus h square by 2 into h. So 2 will get cancelled. This is equal to pi times h into square root of 4r square minus h square. Next what we need to do? Here f dash of h equal to 0, f dash of h equal to 0 for maximum or minimum. That means what is f dash of h? Differentiate this. Pi is anyways constant, so when we equate to 0, we don't need to care about that. This is a product of two functions. That means first function into differentiation of second function. Root x square is 1 by 2 root x, 1 by 2 root 4r square minus h square into differentiation of portion inside. Here r is constant because radius of sphere does not change, only cylinder is the variable, as we have to maximize the curved surface of cylinder. So that means this h is the only variable and small r is constant. We have to treat it like that. Clear now? So how to solve this? H divided by 2 into square root of 4r square minus h square into differentiation of portion inside. This will be constant, so it is 0, differentiation is 0, minus 2h, minus 2h, 2 will get cancelled. Next, plus, again write the remaining. Differentiation of h is as it is 1, we will have square root of 4r square minus h square. Pi is common for both. When we equate to 0, we don't need to care about that. Okay, this value is equal to 0. That means take cross multiply, then we will get minus h square. Here when we multiply, we will get plus 4r square minus h square divided by square root of 4r square minus h square equal to 0. Denominator cannot be 0 as it is a square root function. This is always positive. That means 4r square minus 2h square equal to 0. Here we can cancel out 2, which means h square is equal to 2r square. H square is equal to 2 times r square, or h will be equal to root 2 r. H is equal to root 2 r. This is what we need to prove. Here do we get h equal to root 2 r? Yes. Proof is done. For checking if this value is curved surface area is maximum or minimum, use second derivative test. What we will do? Again differentiate, find f double dash of h and see if it is less than 0 at the critical point. So that is how we should solve. Now we will see the solution. Cylinder is there and it is inscribed inside a sphere, and sphere radius is smaller. Let this be axis of this. So this is small r, and let this radius of cylinder be capital R and height be capital H. The relation is capital R square plus capital H square by 4, that is h by 2 square equal to small r square. This is our condition. Use this condition to write in single variable. So we get this root of 4r square minus h square by 2 is equal to capital R. And curved surface area is given by this. And differentiate it equal to 0. F dash is equal to 0 means we will get, in final we will get h is equal to 2r. And find f double dash at h and substitute the value h equal to 2r. That is our procedure now. So if it is less than 0, that is our maximum point. That is it. Easy questions. Next is last question. Again, prove that the radius of right circular cylinder of greatest curved surface area which can be inscribed in a given cone is half of that cone. Wow, what a question. It is confusing, sir. We will read it bit by bit. What is the first statement? Radius of right circular cylinder. First, while reading such questions, what we need to do is read it bit by bit. What is given first? Prove that, leave that portion. Radius of, leave that portion. Right circular cylinder. Okay, sir. Cylinder is there. Let's make a cylinder first. Right circular cylinder of greatest curved surface area. Okay, this cylinder has the greatest curved surface area which can be inscribed in a cone. So this cylinder is actually inscribed inside a cone. Let this be cone. This cylinder is inscribed inside a cone. Okay, sir. Cylinder is inscribed inside a cone. And what we need to prove? Radius of this cylinder. We don't know the radius of cylinder. Let's take this radius as capital R. Radius of cylinder of greatest curved surface area. Curved surface area is maximum. What is curved surface area? Curved surface area of cylinder is 2 pi r into h, just like how we saw in previous question. So here this h is the height of cylinder. Capital H is height of cylinder. Okay. Greatest curved surface area inscribed in a cone. Let's assume the radius of cone is smaller. Radius of cone is smaller. And height of cone is given by small h. Height of cone is small h. Okay, sir. Next, what we need to do? Now we will make a diagram. we have this portion, and let's make a triangle here at the top. Then we have two triangles. One is this triangle and another one is bigger triangle. Let's take these points as A, B, C, D, A, B, C, D, E. Okay, sir. Now what is the observation? This is an axis. So this angle is actually 90 degrees. Angle is same. One angle is same. And this angle is also same in both the triangles ABC as well as ADC. That means these two are similar triangles by AA similarity. Recall how you learned in class 10 similarity of triangles. So that means when two triangles are similar, what is the property? Corresponding sides are proportional. That's how we should establish the condition. When condition is not given, from the geometrical diagram, we have to understand the picture and see how to form the condition first. That will be, what is the height of this? This height is given by, this height will be equal to, total height is h minus cylinder height, that will be h minus h. And this radius is radius of cylinder, that is r. So this radius r divided by r, last question, r divided by r will be equal to r divided by r is equal to h minus h divided by total h. H minus h divided by total h. Now this is our condition. We will discuss with solution directly as we are running out of time. Sir was waiting, so we will complete this with seeing solution. So we have a cylinder and the cone is inscribed, cone is circumscribed. Cylinder is inscribed the cone. R and h be the height of cylinder. R is small r, capital R is radius of cylinder and capital H is height of cylinder. Similarly, for cone, small r is radius of cone and small h is height of cone. Let's name this. So these two triangles will be similar and we can form the condition based on that. That is the condition we obtain. So that means we have to establish a relation. And what is the variable? This cylinder is the variable. Why is that? Because we have to maximize the curved surface area of cylinder. That means this cone is fixed. So this small h and small r are fixed numbers. Treat it like constant. And capital H and capital R are the variables. So what we need to prove? Radius we need to find. So that means write h in terms of r. So curved surface area is given by 2 pi RH. In the last question we have replaced R in terms of H. Here we are writing H in terms of R. Based on what is asked, we have to choose that. Right now? Okay. Next. Curved surface area is given by this relation 2 pi R into right H. Now what we need to do? Differentiate equal to 0. For maximum or minimum, S dash equal to 0. Then differentiation value is this term equal to 0. These are all constants. 2 pi, capital small h and small r are radius and height of cone. That is fixed. So this is constant. So small r equal to 2 times capital R or capital R equal to r by 2. Now S double dash equal to, this is a constant term into minus 2 which is negative number. So S has a maximum value at r equal to r by 2. That is what we need to prove. So proof is done. Easy questions. Question will look complicated, but for understanding and solving these type of questions, first we need to break into different smallest portions and understand by reading each small segment of the question. Try to draw the diagram and then see what is asked. If condition is not given, then find the condition, establish the condition based on the problem and then solve. Okay students, with that we have completed this topic, and always keep learning and keep growing students. Success is yours line by line. Endigu endendigu namma tapasya.